Today we are going to be starting a couple of day topic over polynomials. So before we get into much detail, we're going to look at some important definitions. And the first definition is, what is the definition of a polynomial? A polynomial is one or more terms added or subtracted together, and all exponents are natural numbers. And to extend on that, natural numbers are another word for whole numbers starting at 1. So I'm going to give you an example of what a polynomial looks like, and then we're going to use that example on the rest of our definitions. So polynomials are multiple terms added together. You can have numbers in front of your variables, and the exponents for the variables have to be numbers like 1, 2, 3, and 4. So here's an example of a polynomial. 2x squared plus 5x minus 7. And we've seen polynomials before. We've seen problems just like that in our previous units. So that's the first definition. That's an example of a polynomial, and we're going to use this example here when we go through the rest of the definitions. Our next definition is degree. Degree is simply the absolute highest exponent in a polynomial. And remember, exponents are those little numbers, okay? So if I look at my example from up here, if I look for the little numbers, this is an exponent. And if I wanted to give this guy an exponent, his would be 1. So which one of those is the biggest? Well, the biggest one is 2. So the degree of this polynomial is 2. The leading coefficient. The leading coefficient is the number in front of the term with the highest exponent. So the term that we were just using, okay, here's our highest exponent. It's the number in front of that letter. So that would be, obviously, the number 2. So this one, the leading coefficient, is the number 2. And finally, constant term. This is a term that does not have a variable. So if we look at our polynomial, this first part has a variable, the second part has a variable, but this part does not. So the term without the variable in our example is not just the number 7, it's the number -7. So those are our first 3 vocab words, first 4. Hopefully there's no problems there. When we look at, let's turn the page, the standard form, okay, this is our next definition. This is a specific way of writing our polynomial. This is a polynomial where the terms are in order from highest to lowest exponent. So, I'll give you a new example to work with. 5x to the third minus 4x squared plus 9x minus 1. If we look at the exponents here, they should go down from highest to lowest. The highest exponent is 3, then it goes down to 2, then of course there is an imaginary exponent there, it's a 1, and anytime you see a whole number without a variable, it doesn't have an exponent. So this is what we mean by highest to lowest exponent. 3, 2, 1, no exponents. Now, the next 3 definitions we are going to use when we classify a polynomial by its terms. So our first vocab word is monomial. Okay, the prefix mono, hopefully you guys know that that means 1. This is a polynomial with only one term. In other words, there's no addition or subtraction signs. Next prefix is binomial, and hopefully you know bi, like a bicycle, means two. This is a polynomial with exactly two terms. And finally, trinomial, prefix tri, means three. This is a polynomial with three terms. Any time we go more than three, we simply call it just a polynomial. So I can give you some quick examples. A monomial, one term. For instance, 6x squared. That's one term. There's no addition or subtraction signs. That's an example of a monomial. Binomial, two terms. Let's go with 3x minus 9. Two terms, 3x and negative 9. Three terms, 4x squared minus 3x plus 8. 1, 2, 3 terms. And again, once we get more than 3, it becomes a polynomial, meaning many. So one of the things you're going to do on your homework is you're going to be given problems like these, and you simply need to tell me which name applies. So we'll look at some examples in just a minute. We have some more classifying to do. There's some more vocab words coming here. We can also classify polynomials instead of by how many terms they have, by their degree. And if you remember, degree is the highest exponent. So the absolute smallest degree that we could have is 0. The name that we give for that, and this is some vocab that you will need to memorize, the name for a 0 degree is called a constant. An example of this, if there is 0 degrees, that means there are 0 x's. So an example might be y equals 2 or y equals negative 8. There's no x's in your equation at all. When the degree moves up to a 1, we now call this linear. Well, linear you should be familiar with. Linear is a line. So an example might be y equals 3x minus 4. That's the equation of a line. You guys have seen that before. When we move up to a 2, we call it quadratic. This is the unit we just finished. Quadratics, y equals 5x squared, because you have to have an x squared because the degree is 2, plus 6x minus 9. So this 2 is what makes it quadratic. 3, the vocab word is cubic. It means you must have y equals x cubed. You must have an x cubed in your problem, and we'll throw in a plus 9x. It doesn't matter what's after it. Okay, on these guys, the most important piece is the first one. With with constant, you can only have whole numbers. With linear, the most you can have is an x. With quadratic, you must have x squared. It doesn't really matter what else you have. Okay, those are the two important ones. With x cubed, or with cubic, you must have x cubed. I don't care what the rest of the equation is, but you must have that. When we move up to degree 4, we get into what's called a quartic function. It must have an x to the 4th. So 3x to the 4th minus 5x squared plus 7. I don't care what else is there. You must have that guy. And finally, the highest one we're going to talk about is 5, which is quintic, like quintuplets. So that means you have to have an x to the 5th. So y equals 4x to the 5th plus 3x squared minus 1. I don't care what else you write down as long as this one is the one that's included. So we are going to take a look at an example that uses all of our vocab. So we have to write the polynomial in standard form and classify by degree and number of terms. I'm also going to throw in 2 more things I want us to do. I want you to tell me, okay, so I want you to add in your directions. Right here, after standard form, I want you to tell me the degree and the leading coefficient. So we're going to add a couple things in the directions. So add those in. So first of all, we have to write our polynomial in standard form. If you remember, standard form was when we start with the highest exponent and end with the lowest one. This little notation here, f of x, just recopy it. So f of x equals, what is the highest exponent here, 2 or 4? Well, naturally, you should say 4. So we're going to start off with negative x to the 4th. Then, this is a positive 2, so we're going to do plus 2x squared. That's standard form. The next thing I asked you to give me was the degree. The degree, if you have to look back on the definition, is the highest exponent. Well, what is the highest exponent in this problem? It is the number 4. So my answer is 4. I then want to know what is the leading coefficient. Well, the definition of leading coefficient is the number in front of this guy. So if I turn to the number in front, I'm looking at that right there. Well, that is a number. It's not just a negative. It is a negative 1. So our leading coefficient is negative 1. Now we need to do some classifying. We need to classify based on the degree. So degree classification, and also by the number of terms. So term classification. So degree classification, we know the degree is already 4. So I'm going to come back here, go down here to 4, and the answer is quartic. And then finally, I need to know how many terms this has. Well, it has 1 term, 2 terms, and 2 meant, 2 terms right here, meant binomial. So we're going to call this a binomial. Okay, so that was just using our vocab. So pause the video. Please try part B on your own. Okay, so let's see how you did. First of all, standard form, the highest exponent is 3, so negative 8x to the 3rd. The next highest exponent is 2, so plus 2x squared. And then the last one is just this whole number all by itself. Hopefully, you knew that the degree, the highest number, the highest exponent is 3. The leading coefficient is simply the number in front of the 3. So that would be that guy, which is the negative 8. And your classification, the degree classification, the degree is 3. Reference our chart. 3 is cubic. And the term classification there are 1, 2, 3 terms. 3 means try, so you have a trinomial. And so that is part of your homework. So hopefully those were pretty easy using the definitions. The last thing that we are going to talk about today is adding and subtracting the polynomials. And we've done something very similar with complex numbers. To add polynomials, simply drop the parentheses like they were never there. Combine your like terms. Okay, these have to have the same exponent. And then write it in standard form. Again, highest to lowest exponent. So that's adding. Subtracting, the only thing we have different, we can't just get rid of the parentheses. We have to distribute the negative. Okay? Once we distribute the negative, we combine like terms like adding and write it in standard form like adding. So, that being said, go ahead and turn your paper. We're going to do both of these together. First question is letter A, adding or subtracting? Well, if we look between the parentheses, that is a plus sign, so this is addition. So I'm going to drop the parentheses. 5x squared plus x minus 7 plus negative 3x squared minus 6x minus 1. Let's look for some like terms. And if you're smart, you'll start with the highest exponent. The highest exponent here is 2. Does he have any like terms? There's another 2 right there. 5 plus negative 3 leaves me with 2x squared. Now let's look for x's. Well, here's an x, and here's a regular x. Well, what number is here? That's a 1. 1 plus negative 6 makes negative 5x. And then we have a whole number and another whole number. And yes, those are like terms. Negative 7 plus negative 1 makes negative 8. And that is in the correct order, and that is done. Let's look at B. Is this addition or subtraction? This time, it's subtraction. So, here's how we do it. First parentheses, don't change at all. 3x to the third plus 8x squared minus x minus 5. We're going to distribute the negative to all of these. All it's going to do is make them the opposite. The opposite of positive 5 is negative 5x to the third. The opposite of negative x squared is positive x squared. And the opposite of positive 17 is negative 17. So just remember, distributing the negative means do the opposite. Now, combine like terms. Highest exponent, 3. Is there any more 3's? Yes, right there. 3x to the third minus 5x to the third. 3 take away 5 is negative 2x to the third. The next exponent is squared. There's a squared, and there's a squared. 8 plus 1 makes positive 9x squared. Then, after squareds, we look for regular x's. Well, here's a regular x. However, that's the only one. He's still important. We're still going to write him down next. And then finally, we have 2 whole numbers. Negative 5 minus 17 gives you negative 22. And that is done. Okay, do me a favor, pause your computer, try these 2 problems on your own. So let's see how you did. First problem was a subtracting problem, so keep this one the same. do the opposite of these. So negative 3x squared, x to the fourth, plus 12x to the third, plus x. We did the opposites. Like terms. X to the fourth, 9, take away 3, leaves me with 6, x to the fourth. Look for threes. X to the third, x to the third. Negative 12 plus 12 is 0. Well, if you get a 0, you can just cross them off. They cancel. After 3 comes x squared. Well, here's an x squared, but he doesn't have any like terms, so I'm just going to write him down next. After x squared comes x. Well, here's an x, but again, there's no more x's, so he has no like terms. And then the last guy we're looking for, all by himself, a whole number. Well, there's no more whole numbers, so it's just minus 8, and that one is done. And let's look at this last example. This one was addition. So just drop the parentheses, x to the fourth, recopy that one, and recopy this one, and start combining like terms. The highest ones are x to the fourth. So 1 plus 2 makes 3x to the fourth. And the next highest one is x to the third, but there's no other one, so it's just plus 2x to the third. And then the only thing I see left are whole numbers. Whole number, positive 8, take away 9, leaves me with negative 1. And I am done. And that's the end of the notes.